So what's true about x and y in quadrant 1? Thank you, Amanda. Positive for both, right? So it's going to be a positive x and a positive y. Okay. And then what changes in quadrant 2? X is negative because you got to go left and then you got to go up, right? So that's going to be a negative positive. Quadrant 3? Negative negatives. And quadrant 4? Positive negative because you're going right and down, right? So your x and your y are always going to be positive and negative. Okay, so remember these things are representing your x and your y's. And we talked about a couple days ago, we did that like general definition, trig functions of any angle, and we had those rules. Sine was y over r, cosine was x over r, tangent was y over x. Okay. Do you remember what was the special thing we need to always remember about the r there? R is always positive. It represented like the hypotenuse, the radius of the circle. And while x and y in the coordinate plane, we're going to allow, even though they're supposed to be like sides of triangles, and we're like, a triangle side is not -3. In algebra, we're going to say like, we're not really saying the length is -3, we're saying the direction is -3. But when we find r on those triangles, r is always positive, right? Okay, so my follow-up question, and we'll kind of jot down this summary of this on the next slide, so you don't really have to be writing all of this down, more of having the discussion. If r is always positive, what do you know about the signs, positive and negative, for the trig ratios in the 4 quadrants? So like, there's 6 trig ratios, right? Sine, cosine, tangent, and their reciprocals, cosecant, secant, and cotangent. What's going to be true about their ratios? Are they going to be positive or negative in quadrants 1, 2, 3, and 4? So go ahead and see what your group is going to say about that.
Oh yeah, because like tangent, sine, positive.
Here you're relying on your ratios from that general definition, right? Sine is y over r, cosine is x over r, tangent is y over x.
Yeah.
Okay, what's true about all the trig ratios in quadrant 1? They're all positive, right? R is positive, X is positive, Y is positive. So if I'm putting positives over positives for each of these, and their reciprocals, positive over positive, it makes sense that they're all positive, right? Anybody find anything interesting in quadrant 2? You raising your hand?
Sure. Cosine and tangent are negative.
Okay, cosine and tangent are negative because cosine and tangent both have x in them, and x is negative. Okay, x is negative, y is positive, r is positive. So a y over r is still going to be positive. That's positive over positive. But an x over r is going to be negative over positive. So that's always going to be negative. It doesn't matter where that is, right? It's always going to be negative. And same thing here, we're going to have a positive over a negative. So that will be negative. So you said cosine and tangent are negative, which of course means sine is positive. And then we can extend these to the reciprocal ratios, right? Like sine's rate or reciprocal cosecant would also be positive. Okay, so what happens in quadrant 3? Sine and cosine are going to be negatives because the x is negative, the y is negative, and the r is positive. So this would be negative over positive, negative over positive. Both of those come out to be negative. But when you get down to tangent, it's negative over negative, which is positive. So down here in quadrant 3, tangent is positive, and cosine and sine are negatives. And then I guess like maybe you could even think about it like process of elimination. What's going to be true in quadrant 4? The only one left is cosine gets to be positive, right? So like just to verify in quadrant 4, x is positive. So when you would do the cosine, it would be positive over positive. So that makes sense. The y is negative, so sine and tangent are both going to be negatives because they're going to be negative over positive, negative over positive. So cosine is positive, and sine and tangent are negative. Okay, so this is just a really nice pattern. If you recognize this, it's a really great way to check your answers for me in this section, because what happens a lot in Algebra 2 and also in Algebra 3 and Pre-Calculus is that students have the right ratio, but they have the wrong sign, positive or negative. Okay? So if you recognize how this works around the quadrant, you can always do like a 2-second double check at the end. Does the sign match what should be true in that quadrant? And then make the adjustment. Erase the negative, add a negative, like whatever needs to happen. Okay, so I like to use it as like a safety at the end to make sure I have the right sign. So if you were writing things down, you know, like as we were going through, that's great. If not, I would make sure to write this part down, like draw yourself the quadrants. And label, I just on this one labeled what was positive. Okay, so if I didn't label it as positive, then it is a negative. So in quadrant 1, all the trig ratios are positive. In quadrant 2, only sine and its reciprocal cosecant will be positive, so everything else is negative. In quadrant 3, tangent and cotangent are positive, and in quadrant 4, cosine and secant are positive. So if you did not write that down, I would add that into my notes. But you know how your geometry gave you SOHCAHTOA? And in the beginning in geometry, when you learned SOHCAHTOA, you might have thought, my geometry teacher is crazy. Why would I ever remember this thing that isn't even a word, right? But then you use SOHCAHTOA so much, and it just like makes sense, and we all, when we get to Algebra 2 and we go on, we all just know what SOHCAHTOA is. So wonderful. Anybody feel that way? Feel that way? I love SOHCAHTOA. We got a way to remember the 4 quadrants. So, we use the first letter of what's positive, and we use the basic trig ratio. So in quadrant 1, I'm going to use an A for all. In quadrant 2, I'm going to use an S for sine, and then of course it's reciprocal cosecant. Quadrant 3 is going to be a T for tangent and cotangent, and quadrant 4 is going to be a C for cosine and secant. And sometimes people remember the ASTC. All. Yeah, if you want to underline, all of them are positive. So some people remember ASTC, and a lot of times people draw the 4 quadrants and they put ASTC in them, like at the top of quizzes and tests, which is great. But we also have another way to remember what order that goes counterclockwise in the order of the quadrants. It's a little saying. It is all students take calculus. True or false, we do not care. All students take calculus. If you want to come up with your own little, are those mnemonic devices when you learn things like that? I can't remember. You want to come up with your own little way to remember it, that's fine. But I'm going to say all students take calculus. And what I mean is say all of them are positive, sine is positive, tangent is positive, cosine is positive. All students take calculus. ASTC. Helps me get those in the right order. Okay, so remember, all students take calculus. Then when you do it at the end of a problem, it should literally take you like 2 seconds. All students take calculus. Oh, quadrant 3, only tangent should be positive. I have left my sign as positive. I will add a negative. Okay, that's all you need to do. Okay, here is just a set of notes of what's going to happen in our examples, and then we'll do a few examples. I'm going to talk more about that circle that I gave you yesterday, and then we'll have some time to work, okay, and practice. Because really, trig here is just about you doing it and trying it. So here's how you're going to be evaluating trig functions without a calculator. And the difference here, like you've done some trig functions without a calculator, it's when I don't really tell you the angle, but I give you enough information about the triangle that you can find the 3 sides. So then you just do like SOHCAHTOA, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. But what I'm going to be doing on these problems is I'm actually going to give you the angle. I'm not going to tell you anything about the triangle. You won't know any of the sides. But I'm just going to give you an angle. And I might say, do the sine of 300, or do the cosine of 215, or do the tangent of 120. Without a calculator. First thing, theta has to be between 0 and 360 and 0 and 2 pi. So that rule should seem familiar from reference angles, right? Okay, so reference angles, we're kind of like building ourselves up to this piece. If they're not, use a coterminal angle. Okay, so that's like old news. We already know that. All right, step 2, figure out what the reference angle is. So we're actually just repeating our steps from yesterday. Find the reference angle in that particular quadrant. Remember that your reference angle should be positive and it should be acute. Now the difference today is that when I say without a calculator, your reference angle is going to have to be one of the special right triangle angles. So 30, 60, or 45. And in radians, okay, you might want to write this out to the side. This will be better or easier if you know these things. 30 is pi over 6. 45 is pi over 4. And 60 is pi over 3. And we can always do the conversion, like multiply by pi over 180, but these, you're going to see them so often, it's best that you just know them. Okay, 30 is pi over 6, 45 is pi over 4, and 60 is pi over 3. 30 and 60, you know, when you switch them over to radians, you get the opposite number. So 30 isn't pi over 3, it's pi over 6. So it's kind of different. But that would make sense because if you divide by 6, it's smaller than if you divide by 3. Okay. Then you're going to draw the triangle in the correct quadrant. So you found an angle between 0 and 360. So it sits in quadrants 1, 2, 3, or 4 as a positive angle. You found its reference angle. It's either 30, 60, or 45. You will draw the triangle back to the horizontal axis. It will be one of the yellow, pink, or green triangles like my back wall. And then because you know about the ratio of side lengths for a special right triangle, you just label the sides. Right? 1, 1, square root 2. 1, square root 3, 2. Now I did put a little note here, because you're putting this special right triangle not just out in space like in geometry, we're attaching it to the coordinate plane, you should label the signs for x and y correctly so that your ratio will have the correct sign in the end. So if you're going left, you have to label your x negative. If you're going down, you have to label your y side negative. Otherwise, they'll be positives for right and up. Remember that your hypotenuse or your radius is always going to be positive, so you'll never have to put a negative on that. Step 4, do the trig ratio that I'm asking. So I might be asking sine, cosine, tangent, or one of the reciprocals. So you can think about it as y over r, x over r, y over x, or flipped. And the last step is really, like, you don't really have to do a lot for this. I just think it's beneficial because those signs are going to get us. Use all students take calculus to verify if you have the correct sign. Right? So if you decide that that is a tangent in quadrant 3, all students take calculus tells us it should be positive. So if you have a negative, erase it. It's just a way to double check. So we're putting together our unit circle, which we right now only use the unit circle for the quadrantal angles, and unit circle isn't something that you'll learn until next year, Algebra 3 or pre-calculus. So we're doing it what I would call like the long way, so we understand how these ratios appear. Next year you'll take a shortcut, but the shortcut is all just memorization. You're not actually doing the trig. Okay, here's an example. We're going to do this without a calculator. And your quiz and test going forward are split. One part is no calculator, one part is calculator. So when I hand out the no calculator part, everybody's desk is clear of calculators. You work on it, you turn it in, and then you can have out your calculator. So there are problems you have to do without a calculator. Okay, the sine of 135. Like normally if I had my calculator, I'd make sure I was in degrees, and then I would type in sine 135 and I would get a decimal. Cool. But without a calculator, I'm going to have to do a little bit more work. So, number 1, is your angle between 0 and 360? Yep. Okay. Number 2, find its reference angle. So I usually draw a quick pick of 135. 135 is in which quadrant? 2. Excellent. So when I'm finding this reference angle, theta prime, aren't I doing 180 minus 135? Because they're a linear pair, supplementary. And 180 minus 135 is 45. So what that's saying, because the reference angle is 45 degrees, this is like equal to the sine of 45. Okay, but we have to be careful because we're in quadrant 2. Okay. Now we know in quadrant 2 all students take calculus that sign should be positive. Okay, so we'll check that at the end that we have a positive sign. I'm trying to decide which one I'm going to do. Okay, so I'm going to use red, and I'm going to draw a triangle in this section. Okay, we're saying that that angle, theta prime, is 45. So then I can label the sides 1, 1, square root 2. Right, that's true of a 45-degree triangle. Legs are 1, hypotenuse is square root 2. But because this is on the coordinate plane, aren't I going left 1, up 1? So I'm going to add that one to be a negative. Okay, if I draw the correct triangle. And then I do the sine. So the sine for this angle would be y over r, opposite over hypotenuse. So 1 over square root 2. Rationalize your denominator. Answer is square root 2 over 2. Oh, don't you already know that from that little half sheet, pink sheet that you guys did? That homework assignment? Doesn't that sound familiar? Okay, so if you also want to have out your half sheet, pink sheet, like those are the same answers. You're going to keep getting them. Now, all students take calculus. Is my sign positive? Yeah. So I've got the right answer. Square root 2 over 2. Done. If I asked you to do cosine of 135, the cosine of 135 would have been negative 1 over square root 2. Rationalize our denominator, we would have gotten negative square root 2 over 2, which would make sense because cosine is negative in quadrant 2. Okay. What if I give you a radian? Secant of 7 pi over 6. Well, look carefully at your angle. Is 7 pi over 6 between 0 and 2 pi? 7, 6? Yeah, it's 1 and 1/6, right? We did that one, I think, on the board. So it's ready to go. I'm going to draw myself a picture. That one lands in quadrant 3. I really want the reference angle right here, theta prime. So for theta prime, 7 pi over 6, I'm subtracting pi, the first two quadrants that I don't really care about in quadrant 3. So it's yesterday. Which, this is like 1 and 1/6 minus 1, so don't we just get pi over 6? Okay, that's the same as 30 degrees. Thank you, Madison. No, I appreciate it. I love it when you guys talk. You're always so quiet. Well, you're not as quiet as some of my classes, so I don't ask you about it too often. It is first hour. I accept that. She's awake though. I like it. 30 degrees. Okay, so that means I'm going to draw over here a 30-degree triangle. Opposite of 30 degrees is 1, the shortest side. Opposite of 60 degrees is square root 3, and the hypotenuse is 2. Now, I'm on a coordinate plane, and I'm going left and down, so my x and y should be negatives. Okay. And then I've got a triangle. So now I can do secant. Secant is reciprocal to cosine. Cosine theta is x over r, so secant theta is r over x. So 2 over negative square root 3. Does that seem right? 2 over negative square root 3. Gotta rationalize that denominator. So I'm going to multiply by the square root of 3 on both. And I'll get negative 2 square root 3 over 3. That looks familiar if you have your little half sheet pink sheet, right? You should have seen that as answers in the 30, 60, 90 when you flip the square root of 3 over 2. And then if you do that quick check at the end, all students take calculus. In quadrant 3, only tangent is positive. So since I'm doing a secant, it should be negative. Do I have the negative? Yeah. But do you see how easy it would be for people to not label these negatives? They'll be leaving the special right triangles and forget about direction. Okay, so that all students take calculus is kind of like an insurance plan to make sure you get the right sign. Questions you guys got for me? Okay, I just want to show you one example where I'll go back to that one in a minute. Where it's not between 0 and 360. Okay. So just remember, if I gave you something like this, the tangent of negative 300, I shouldn't find a reference angle for a negative angle. Okay. The rules for the reference angles only work for angles between 0 and 360. So if your angle is in between positive 0 and 360, a positive angle, find a coterminal. So I just add 360. Ooh, what does that make this? Tangent 60. So I don't have to find the reference angle. There it is, right? It's already positive. It's already acute. It's in the first quadrant. Label the sides. Okay. Across from the 30 is 1. Across from the 60, square root 3. Hypotenuse is 2. Everything is positive in quadrant 1 because we're going right and up. Radius is positive. And tangent is y over x. Square root 3 over 1. So square root 3. All students take calculus. I love an angle in quadrant 1 because everything is positive. I don't have to worry about it. Okay? I'm going to give you some time to do some practice. You guys need to do it. I've done 3. Okay? But you guys need to get some practice for yourselves. So I'm going to give you this packet. Do not fear. Okay? This is like all the worksheets for the next whatever days of Gold Sheet worksheets you have. So remember, we did that for matrices. That way all your worksheets are in one spot. Okay, so the first worksheet is front and back. It says worksheet, trig functions, and special angles.
Oh, I know. That's huge.
That's what we're working on right now.
There's a girl at my school when I was in elementary, so very little school.
Okay, so like ideally, you'd work through as many of 1 through 12 as you can right now. Ask questions, get help. If you're confused, let me know. Check with your neighbors. You should have the same ratio, you should have the same sign. So I'm going to give you some time to work on that.